Alright, since I know everyone in here is ready right now, so let's see. Class?
Yes.
Donatello, where were you? Come on now. Anyway, alright, so we're going to go over the review for the test. Now, we're going to go item by item, and I'm going to try and use some of the stuff that you have in your notes already. So, for this first one, we're trying to find A, but I'm going to use this right here. Can someone tell me what type of angle that one is there? If you want to look at it in the notes, can you tell me what type of angle that one is? What type of angle? It is 82. So if you're looking at the notes, okay, this is going to be a central angle, where that right there was in, okay, on page 9 for my notes. So if I'm going through my notebook as I'm doing this, this is on page 9. That is a central angle. So if my central angle is 82, what do you think my arc out here should be? 82. It's going to be the same thing. The central angle is equal to my arc. Now, over here, for the next part, I'm looking for an angle way over here. Now, where angle A is located at, that's a different type of angle. Can someone tell me what that one is called? I heard it. Inscribed, very good. That's going to be inscribed angle. Now with my inscribed angle, and it has the same endpoints right here. So that angle A should be how much?
41.
Why is it 41? It's going to be half. So the inscribed angle is always going to be half of my arc. If my arc is 82, I divide my A by my 82 by 2, and I get 41. So A is 41. Now, we're looking for B. On this next one, we're looking for B. So I'm going to start with here. So this point here and this point here all go with this angle. And that 35, what type of angle is that 35?
Right.
Nope, it's not right. It's wrong. See what I did there? See what I did? Yeah, okay. Geometry jokes. So this one right here, we just said it. It's inscribed again, isn't it?
Yeah.
Okay, very good. So it's inscribed. So we know that the inscribed angle is supposed to be half of my arc. So if the inscribed angle is half of my arc over here on the outside has to be, I heard it? 70. That's 70 because the inscribed angle is half of the arc. So that makes that true. Just like over here, I have 82, and this one over here, we said was 41. Okay? Now, I'm not looking for that piece, but I need that information for my next part. My endpoints are here and here for angle B. What type of angle is angle B? That is inscribed again. We know that the inscribed angle should be
45.
half of the arc, right?
Right.
Yes, it is 35. It is 35. So the inscribed angle is going to be half of the arc. So B is going to be 35. All right. So now, it gives us some information on this next one here, but this one is slightly different because this line right here goes directly through my center. Goes directly through my center. So if that goes directly through my center, how much is this over here going to be?
65.
It is 180. That is 180 on that side. Because the whole thing is 360, right?
Right.
Oh.
So my arc is 180. So the arc is 180. And let's look at the endpoints. Endpoints there and there. I know this one might seem kind of weird, but that angle right there is what type of angle? It is right this time. It is right, but isn't that one inscribed? That one's inscribed because I have my endpoints here, and the angle, the central part right there is going to be touching the outer circle, right? That is also inscribed. So since that's an inscribed angle and my endpoints are here and here, it should be half of my arc. If 180 is my arc, half of the arc is going to be 90. So that makes this one a right. But that's not the one I was looking for. I'm going through and using the information that's given to us to actually find all these things. I know this triangle, which is going to look like this. I'm going to move it over here. If that is a right angle, that one right there is 65. All three angles together in a triangle have to add up to 180. Very good. All three angles in a triangle add up to 180, right? Okay, so I have a right angle, which is 90. So this one right here is 90. So I just need to find that missing one right there. So because of that, that's going to be 180 minus 90, which gives me 90, and then minus 65, which is going to give me 25. So my missing angle over here is 25 degrees. All right, hopefully you guys are writing this all down, right? Especially if you didn't get it. Use the information I've given you to actually work your way through.
Wait.
Okay, so find the angles marked with the letters. This one right here. We're going to use the same information we just did for the last one, but now this one is just looks a little bit more complicated. So I'm going to start with here and here. What type of angle is that? That's an inscribed angle. Very good. And I know the inscribed angle is half of the
35.
half of the arc, right? So if my inscribed angle here is 35, the outside arc is 70. Very good. So hopefully going through item by item is going to help you here. Now, let's find this one. So using those endpoints right there, now looking at that, look at the endpoints for G. So right here, this is the exterior arc. And G is what type of angle?
Unscribed.
That's an inscribed. So an inscribed angle is always half of my arc. If my arc is 70, what's G? 35. I'm going to have 35 right there. All right, so that being said, let's go through, find, yeah, I'm going to do this. So let me erase so I could actually highlight the pieces that I'm looking at. So the next one now is going to be right here, endpoint there, and endpoint over there. So this 74 degrees right there is what type of angle?
Unscribed.
It's inscribed. You notice a pattern here, right? We're all dealing with inscribed angles. all these inscribed angles, it's half of my arc. So if 74 is half of the arc has to be one what? Very good. 148. Very good. Okay. Now, using that information, now going back to the other one, and this endpoint here and this endpoint here is also for this. Let's look. That is my inscribed angle, and it has the same endpoints as that arc. So I know that the inscribed angle is going to be half of my arc, right? So F is going to be 74. Are you okay? So I erase because now we have to find H. Now, this one right here has to do when I have chords crossing in the interior of my circle. So for this one right here, it's going to be, for my formulas, this arc, I'm going to add those two together and then divide by 2. That's from the formula. That's going to be, again, I believe it's on page 9 for that one also, or... Okay, so this one's page 17. These notes are on page 17 for this one right here. So I'm adding my two arcs together and then dividing by 2.
Which example?
This is on page 17 and it is example, it's a second example, so it's 11.5.2. That's the example that it goes with. But if you notice right here in red, I don't have all the circle, right? But do I have everything else?
Yeah.
I have everything else. So I know that the whole circle has to add up to what?
180.
360. The whole circle adds up to 360. So what I'm going to do is I'm going to find the red just by subtracting it. So it's going to be 360 minus my 70 minus my 148. Okay, can you please do the calculations for me, since I'm not very good at math and I need you guys helping me on this? You said 171? I don't think it's 171. What is it? 219? 218? 222. This guy says 222. 142?
Yeah, 142.
Okay, 142. Okay, so we get 142. Now, looking at the formula said when I add these two together in red, it's 1/2 is going to give me this angle right here, H. Half, so it's 1/2 times 142. What is half of 142? I heard it. 71. So H is going to be 71.
Wouldn't it be like a less complicated way to do it? Because like we already have G and we also have 74.
Okay. So you want to try it?
Well, just like
I can. So there's more than one way. I'm just using the formulas that I gave out. Okay. How are you seeing it?
I just like say it's
Which one?
that angle right there, yeah.
This one here?
I just like assumed that was equal to H because like both of the triangles already have like two of the same angles.
Good job. We haven't talked about similar triangles, and so that's the reason why I did not mention that. But yes. Okay, so now he brought up a good point. He said that H and the one right above it is going to be similar triangles because that right there is going to be vertical angles. Okay, in geometry we learned the term vertical angles where vertical angles are congruent. So because of that, we had this was 74 and this right here is also a triangle which that I could add up to 180. Very good. And you still get your 142? Not 142, 71, right? You're still going to get the 71, just a different way. I didn't want to actually try and put anything out there that we did not do yet. So, I myself, I didn't know if you guys actually did it, doing those and doing the geometry earlier. So, I'm just going by what the notes that I already gave. But yes, good job though. Good call. All right, so let's take a look at question 3. So, let's take a look. So we're going to go through and we're going to use all that information given to me, to solve for the rest of the stuff. Let's start with e to f. What is e to f going to be? 64, right? Because that is the same as the central angle, right? It goes with the central angle. So that's 64. Alrighty. So now, using the information I have, this angle G over here is what type of angle?
I know, no.
It's inscribed, isn't it? Is angle G down here on the edge of the circle? Yes, it's inscribed. What do we know about inscribed angles? They are
Half of the.
half of my arc. So if my arc is 64, half of 64 is? Say it again. 32? Half of 64 is 32. So angle G, right here, the whole thing is
32.
32 degrees. So the whole thing is 32. But that's why this thing here, over here, is going to kind of tricky, right? They gave you this side is 22. And so from O to G to F. O to G to F. O to G to F, which is this one right here. What is O to G to F going to be? I heard it?
You said O to G?
O to G. Here, I'll do it. Yes, it is. I'm going to do it right here. O to G to F. Because the whole angle of G is 32. But this one side is 22. And so my missing side that I don't know is now going to be 10 degrees, right? There's 10 degrees for this one.
How would this 10 degrees?
Okay, so are you ready?
Yeah.
So let's look. Here, all the way to here, we said was 32, right? Okay, so now just looking at that angle from here to here is 32 degrees, right? But from here to this way is just, this one was 22 on this side. And so my missing side over here, which would be this, is what I'm looking for, right? Both of them together have to add up to 32. Since they both have to add up to 32, but this side's already 22, so the piece that you're missing by subtraction, so 32 minus 22 is 10. That's how we get that one. Okay, so what's the next one? OEG. OEG. I haven't found this one yet. I will find it in a minute. So OEG. Next one is going to be OFG. OFG. Okay, we can get that one here in a moment. FEO, FEO, I'll get that one. EFG, EFG. Okay, all right, we'll find those ones here. So now that I have a lot of this stuff here, we took care of that outside part. Okay, we took care of that outside part. Now, this one right here goes from here to here, right?
Right.
Now, it makes a triangle right here. But O to F and O to E, can you tell me what those are? From O to F and O to E are what?
60 is 64.
Nope. Identify them. Tell me what they are. Central, but are they start at the center of my circle and go to the edge? What starts at the center of the circle and goes to the edge? Starts at R and then radius. Radius, very good. What do you know about all the radius in a circle?
They're all the same.
They're all the same. All the radius in a circle are all the same. All the radius in a circle are the same. So, given that I know this is a triangle, this piece and this piece are going to be congruent. Those are going to be the same. Okay. So, this is another thing that we know. What type of triangle do we have here? If two sides of the triangle are congruent, they are both the same, what type of triangle is that? I heard it. Good job. Give yourself a high five. Okay. It is an isosceles triangle. Isosceles triangle have special characteristics. The legs are the same. In an isosceles triangle, the legs are the same. So these are also the same. So those pieces are going to be the same. So I know that all three in a triangle have to add up to 180. That's all triangles. All triangles have to add up to 180. So what I'm going to do is, I know that both of these are going to be the same. So let's start with 180 minus 64. And that's going to be 116. Okay? So on those two triangles, or that one triangle right there, the two angles, both of those angles have to be the same. So what would I do if I know that both angles together have to add up to 116 and both the angles have to be the same? Divide by 2. Very good. So I would take that 116 and divide by 2 because both of those are the same. So I just take this and divide by 2, and that's going to give me, what's that going to be, 58? 58. So E here and F here is both 58. So both of those angles are 58 degrees. So that one was, let me see, FEO, 58 degrees. OFE, OF, let me see, EF, EFG, okay, not there yet. And OFG, OFG, okay, we'll find that one here in a minute. And OEG, OEG, I'll find that one too.
It just goes around. Just goes like this.
Alright, so now we're going through, we found a whole bunch of stuff already. We found a whole bunch of stuff there. So, let's see. The next thing that we know, let me see, from there, this side here is 10. And, is this,
Not an eraser.
ah, dang it, okay. This one here, and this one here, are those also radius?
Yeah. They're not.
Yes, they are. From O to G and O to F. from the center of a circle to the edge is always a radius. And if all the radius are going to be the same, I could say that, what type of triangle do I have over here? What type of triangle? I heard it, isosceles. But didn't we say that this isosceles triangle right here, what did we say that little angle is right there? 10. If that little angle is 10, and we just learned from my previous that the base angles in an isosceles triangle are going to be the same, right?
Right.
So I have that one and that one. So what do you think this side over here is going to be? That one's also going to be 10. Karen, you following? Look like you zoned out there. It's okay, as long as you come back. Now, radius. Again, let's look at this radius. That one there and that one there. So over here on the left-hand side there, is that also an isosceles triangle? Yes, it is. It's also an isosceles triangle, and the base angle here is 22. So the base angle over here must be, there we go. So let's see, since we just found some other stuff, that's going to be OEG. OEG, there we go right here. OEG is 22. What else did we find? We found OFG. OFG, we said was 10. And what else did we find? EFG. EFG. Okay, so EFG is right here, from here all the way to here. This outside little piece, okay, this outside little piece is going to be how much? 10. And what did we say this inside angle over here was? 58. So to get the whole thing going from here all the way over here, what do you think I should do with those two values? Add them together. So we're going to end up with 68. 10 and 58 is going to give me 68 degrees. Now, that's a whole bunch of crazy, isn't it? Did we do a lot of stuff? Okay, so did you write down notes on this so when you see it again on the test, you'll be like, hey, I remember doing that. This is what we did to get that answer. Or did you just zone out? Okay, not implying anyone in here zones out. Because I am super boring. I really am. I'm so boring that I got people with earbuds in currently right now. But you ain't heard it from me because you got your earbud in anyway. Thank you. All right, let's keep going then. Keep going. Find X. The story of my life. Okay?
Oh, what?
Yep, hey. Story of my life, right? That's why I always tell you guys. I'm like, seriously, find my X. Find my X.
Yeah, that's
Okay? See what I did there? See what I did? A macho. Hey, do you get it?
Yeah.
Find my X. My X. Anyway, all right. Now, I'm going to look at this. Right here and here. Is this arc here? Now, right here and right here, do they have the same arc?
No.
Yes, they have the same arc. If they have the same arc, what do I know about those values that they have the same arc? They're going to be the same. Just like what we had up here on this problem right here. Both of these had the same arc, so I know that 35 and B are the same, aren't they? That's how I got that this side over here is also 35. If they have the same arc, they are congruent. If they have the same arc, they are congruent. So I know that since these two have the same arc, they are congruent. So I could say that 2x minus 18,
As long as they're both inscribed, right?
yes, they have to be inscribed, yes.
Is it 12? No, it's 12, yeah.
Yes. So, because they're both inscribed.
right.
So is going to be x plus 7. There we go. X plus 7. Let's go ahead and do a little math, a little bit of algebra.
There you go.
At 18. Let's see what we get. On the left-hand side,
Is -1?
I just get 1x, right? Okay, and negative 18, positive 18, that goes away. Equals my negative x minus x, that also goes away. And then I have my plus 7 and plus 18. So x is 25. There we go. Not bad, right?
No.
Okay. Now, did you write yourself a whole bunch of notes on this? I hope so. So, that means that, okay, I'm going to leave off here. We're going to pick up the rest of this tomorrow. Okay? Now, if you did not attempt these problems yet, I want you to. I want you to go home and try these so you come in here tomorrow with some inkling on how to do it. Make sure you all like, share, and subscribe.